cloud architecture. When I say open cloud architecture, so as we already identified in the, I would say, cleared in the previous topic, that Open Nebula, which will give you the clear-cut a platform, which is open source platform for you to create your own enterprise cloud. When I say enterprise cloud, which is nothing else than the advances in your data center, because so in your data center virtualization, whatever which is already available, you are extending that and using it for your own private cloud sake. That is what you say, that enterprise cloud. So this OpenAbula is one such open source platform. It will allow you to create and manage the enterprise cloud. Because why I am stressing up this manage in the sense, so at any point of time, maintenance or managing is so important in every aspect. It is not just about develop and leave it. At anything, once you create or develop, how much ever the importance you should give for the development or the creation, the same kind of importance you should also give for managing or maintenance. So only this OpenAbula is such open source platform which will allow you to create and manage such kind of enterprise clouds. If you ask me what is enterprise cloud, it is earlier days we had only with, you mean to say it is data centers. Such kind of data centers itself we have improvised to be a with respect to any such kind of individual startups, or you say that enterprises are a small based small scale companies, so where they started using this kind of enterprise clouds. Now this OpenNebula, as we already highlighted in the previous topic as well, OpenNebula integrates a virtualization, a storage, networking. That is where we are calling it as where it is providing the IaaS, infrastructure as a service, right? And also it will provide you the multi-tenancy and auto provisioning, and also elasticity, where you may also think of increasing the and resources. I mean, increase and decreasing the resources. You may also think of like scale up and scale down. And this OpenNebula follows the bottom-up approach. See, when we say that bottom-up approach, so it is with respect to the end users and the cloud service provider. Here, as you are only creating the cloud service provider, I mean, say, cloud infrastructure for your sake. So anyhow, we'll be discussing how you can think of. So finally, how those services, whatever which are aligned, what are all the services which are aligned, so those should be fall in. Now how they are falling in the sense, right now we are talking about, it will be in the means of bottom up approach. So a few examples such whichever is admins, DevOps, and end user, based on those needs. So we'll be, the services which are aligned with in a bottom-up approach to be. Now, talking about this, open cloud architecture in a brief way, what are all the different major components which are there in this, cloud architecture? That's what open cloud architecture. What are the different components are there in the sense? There are four different components for your information. Very first component is front end. You can see this is the front end, OpenNebula front end. So that is where it actually runs the OpenNebula services, and it will give you the access to the users. That's what we say, that it provides the user interface API, user interface. That is the front end. That's the very first component of the open cloud architecture. The second component is the host, which you may also call it as nodes. What it has in the sense, this host is the one which actually has your virtual machines, which actually has a virtual machines. So all the virtual machines will be running. So the place where the virtual machines are running, and where exactly those virtual machines are running, definitely on the hypervisors. These concepts we saw in the very first module. So every individual hypervisor may have multiple virtual machines on it based on the available resources. How many resources can be virtualized to what extent? So host, whenever you talk about the host, that has hypervisors, above the hypervisors, VMs, right? That's what we say, that host are nothing else than hypervisor enabled servers to run what? To run the VMs. That is the host. That is the second component in the open cloud architecture. The third component in the open cloud architecture is data stores. So it is the storage system. It is a storage system to store what? to store the virtual machine images, virtual machine templates, and also the runtime entire data. It will be stored in the data stores where, so that is the third component we can say, so which is data stores, right? So where it may allow you to use both, we say that SAN, which is, I hope you know this, SAN, which is storage area networks, and or it can also be the NAS, which is network attached storages. So we say it as the different types we have. So majorly we'll be using the SAN storage, which is storage area networks. So storage system we have as a third component in the open cloud architecture, which is data stores, that is to store the VM images, templates, and runtime data. The fourth item or the fourth component, okay, fourth component we have, which is nothing else than the physical networks. I call it as service networks, you may call it as. What it is doing, it is as the term only says that it is network. What it is doing, in the sense, it is connecting the other components. What components? It is the front end is the one component, host is the other component, and storage is the other component, right? So as we have the three different components like front end, hosts, and the data store, to connect all these three and provide the better communication, for that we have a, you call it a service network or physical network. It is a, I call it a simple networking is one such component in the architectural I mean it's a cloud architecture, as open cloud architecture you call it as. So likewise there are four components, okay, there are four components under this open cloud architecture, which is which is front end, host which that has the hypervisors. Above the hypervisor there are the n number of VMs. All those VMs can also be communicated with each other by means of VM networks, right? So now the other component is the data stores for storing the entire data related to that cloud services. Then there is a one network to provide the better connecting and communication between the other three components like front end, host, and the data store. That is what with respect to the components in the open cloud architecture. Next is how these are designed, if you ask me. So obviously the cluster like design, the this open cloud architecture is designed like a cluster of what? Cluster with one front end, that's what here, one front end, multiple hosts, okay, multiple hosts, and every host may have multiple hypervisors, every hypervisor may have multiple VMs. That's what multiple hosts and multiple nodes, and those can be, that's what we say is modular and customizable. That's what you can do the, it has a flexibility to scale up and scale down. It is a resizable, and it will supports what? So obviously it is supporting the virtualization, is it not? It is supporting the virtualization at the hosts. It is supporting the, is it supporting networking? Definitely yes. We have a networking, which is physical network, you call it as a service network itself as a one component to connect these things and provide the communication. We have a mechanism for storage, which is the data stores, and also there is a authentication is also provided in the open cloud architecture. So those are the some of the highlights of the open cloud architecture. Now let us start discussing every individual component in detail. Start with very first thing is that dimensioning of the cloud, or dimensioning the cloud. What do you mean? What do I mean to say the dimensioning of the cloud? So dimensioning, as term says, that you should have the, it is a process that deal with what? Plan and size about the cloud infrastructure. That is what first, as I already quoted in one of the previous slide, before you can think of using the Open Nebula for creating the private cloud, you must have the complete awareness about the design. That's what the things which I told in the previous topic as the overview about the Open Nebula. So you should have the complete awareness about the design. When I talk about the design, it can be infrastructure, it can be the provisioning model, so it can be the backend virtualization. You should have, one should have the entire awareness about that. That's what even I'm trying to convey here. That dimensioning the cloud, you must have the a clarity on planning and sizing of the cloud infrastructure For what? For meeting the expected performance, scalability, and also very importantly, the cost requirement. It is not like everybody can spend how much ever you want. No, one should have the clear cut idea. See, in some cases it may vary, but you must have the idea first of all. So you all this, you should have the clarity. That's what the planning and sizing of the cloud infrastructure. So for what, in the sense, for making sure that performance is good, scalability it allows, and also cost requirements are in a clear cut picture, right? If you ask me what are the different key factors whenever you think of dimensioning the cloud, what are the key factors one should know? In the sense, very first item is what? Workload. What do you mean to say this workload? How this is measured? In the sense, that is measured with respect to the how many VMs I want to provide the services. How many VMs I want to provide the services, and what type of VMs are those? That is what workload size. Next is storage capacity, as we saw in the previous slide itself. So what is the capacity I should provide, I should have to give the services? What kind of networking I should have to connect those core components like front end, data stores, and also the host, to connect them. What kind of connecting networking device design I should have? The last one is hardware requirements with respect to both front end and also the nodes, which is nothing else than the hosts, to hold the hypervisors, and above the hypervisors to hold the VMs. What kind of hardware compatibility I should have? So likewise, whenever you are trying to dimensioning the cloud, you must have the clarity on these key factors, like workload size, which deals about the number of VMs and also the type of VMs, storage capacity, networking design, and the hardware requirement. Thus, if you ask me what is the basic requirement, what is the basic recommendation, okay, for a basic configuration required to you start using the Open Nebula, in the sense, we usually say that RAM. When I say memory, in the sense RAM. So the RAM capacity should be minimum of 8 GB. CPU can be one CPU with the 4 cores. That's what the quad core, a 4 cores. So CPU, and disk space, which is a hard disk space, minimum 100 GB. If you have, that will be very good. And also the networking. So if you have the two NICs, network interfaces, so if you have the two NICs, that will be so good. So like this is the basic configuration to start with any Open Nebula for your own enterprise cloud for your private requirement. So if you create any kind of private network by using this, based on this configuration, like 8 GB RAM, one CPU with the 4 cores, and you say 100 GB disk, okay, so then two NICs. So what it can it can serve, okay, how much it can serve? In the sense, it can serve up to, it it can serve up to 2500 hosts. Okay, it is suitable up to 2500 hosts. And what 2500 hosts, it means to say that those many hypervisors you can have. Okay, and on every hypervisor you may have 10,000 virtual machines. Can you build 10,000 virtual machines? Now if you see this workload size, number of VMs, it is 10,000 VMs on every hypervisor. And this configuration will allow you to create 2500 hosts, and on every host it is 10,000 VMs. So you can think how many VMs you have. It is 2500 into 10,000. Those many VMs you can place on this virtual environment with this simple configuration of 8 GB RAM, 2 NICs, 100 GB disk, like that, right? So on this very first type of node, when I say that those many instances you can place on the hypervisors. So as we already mentioned, this open cloud architecture will allow you to use the two different kind of hypervisors. One is the KVM, the other one is the LXD, right? KVM and LXD. So start with the KVM. So which is nothing else than the kernel based virtual machine. So kernel based virtual machine is one such hypervisor which can be deployed, so which can be placed on any data centers to do what, in the sense where it can hold multiple virtual machines, and it can run. I'm repeating. So KVM is a our hypervisor. So it is the hypervisor which can hold the other VMs. Okay. So the other VMs can be deployed onto the KVM hypervisor and do create the virtual environment. For doing such kind of KVM environment, okay, for doing such kind of KVM node environment, what is the basic requirement you need? In the sense, definitely you don't need any separate, that's what, no overcommitment, because as already I spoke in the previous slide, what is the basic requirement to create your own, start using the OpenNebula, so that itself is more enough. So in that, one CPU with the, one CPU core per VM is enough. Whenever you are creating the VMs on this KVM hypervisor, only one core per VM is enough. Okay, so in that case, see, as we saw in the previous slide, we had one CPU the 4 cores, right? Which is the hyper OpenNebula basic requirements. So here I'm talking about, if you allocate one core per VM, okay, one CPU per one VM. So if you have 40 VMs and if you allocate 2 CPUs, okay, so it's something like 80 cores. But what is the basic requirement I'm saying? It is one CPU per one VM, that is enough. Okay, if you have 2 cores per VM, that is also, it is also considerable. Next is, what is the memory planning? In the sense, you can think of 10% of, only 10% of overhead. So whenever you are creating, example, if you are creating the VM on any hypervisor, if the hypervisor has 100 GB, example I'm saying 100 GB. So basically, whenever for this VM, you should that's a basic scenarios where we follow 10% of the available hypervisors resource will be allocating to this particular VM. That's what usually we do it. So in that case, where, the number of VMs we'll be creating on the hypervisor. So for everything, sorry, for all those VMs, you can share across. Okay, that's a first basic awareness about the KVM, which is kernel based virtual machine. It is a one type of hypervisor which is supported in the OpenNebula, which is a part of your open cloud architecture. The other type of this other type of hypervisor is this LXD. The other type of hypervisor is LXD, which is Linux Container Daemon. Okay, Linux Container Daemon. So again, as usual, in the OpenNebula, LXD, which is Linux Container Daemon, is also the hypervisor. For what it is? Again, for acting like a hypervisor to to place the containers and orchestra. So what I'm trying to convey, in the KVM, where you place the multiple VMs on the KVM hypervisor. So here I'm trying to convey that in the LXD, you can think of deploying the containers above that LXD and managing them. Okay, so if you ask me which is when you compare to the LXD and the KVM, okay, which is more utilization of resources, in the sense, this LXD will make use of low resources overhead when it compares to the KVM. Again, that's what, better resource utilization. This LXD will provide the better resource utilization compared to the KVM. So like that, these are the two kind of nodes you can think of in the architecture. So this is what the architecture I'm talking about. Under this hosts, okay. So there are the two types of hypervisors. One is the KVM, the other one is the LXD. KVM, where you can have a multiple VMs about that KVM hypervisor. LXD, you can think of deploying the different containers on at this host part, right? Those are the two two types of nodes you can think of whenever you are dimensioning the cloud. Now moving to the storage requirements. Whenever you think of storage requirements, as I already mentioned in the diagram, so there are the data store for storing what? So there are the different kind of storage requirements. So as I already mentioned in the diagram, like it can be part of SAN and NAS. right? So to store what you may be storing the images or system data store. See, when I say image data store, where it will be storing the VM images. Whenever you say that system data store, where it is to store the disk files, it is to store the VMs, disk files and the volatile disks. Whenever you talk about the file storage, so where it will be storing the context files, kernels, okay, RM, disks. So like this, so these are the three I can say the three classifications of the storage data in the in your data store of your Open Nebula, which is nothing else than your open cloud architecture. So if you talk about the example, what is the medium size, for any medium size cloud, what is the minimum storage requirements? Whenever you are thinking of dimensioning the cloud, at that time, what is the minimum storage requirements you want, right? In the sense, obviously, let's assume that it has a three servers. Okay, you are creating a three servers where each server with, okay, 5 into 1 TB, which is terabytes disk space, 16 GB RAM, okay, two CPUs with 4 cores, two CPUs with 4 cores and two NICs. So those are the minimum or the average requirements of the storage for to manage the data store in the cloud architecture. Similarly, we had another component for to deal with the networking. So to connect all those parts. So whenever I am planning, what is the minimum requirement I should have, in the sense, obviously for dealing with the communication with the front end, I supposed to have the network interfaces. So that's what for giving the services to the public or the public services. So I must have the two NICs. Okay, to connect with the nodes or the hosts, I may have up to 4 NICs. To support with the multiple drivers, when I say different drivers we have, it is the dummy drivers. All this I'll be expanding in the next slide. What I'm trying to convey, whenever you are thinking of planning the private cloud in the Open Nebula, that's what dimensioning, as I mentioned in the one of the previous slide. Dimension cloud is nothing else than a planning to create the your own private cloud and manage it. For that, what is the basic storage requirements, what is the basic network requirements, that's what I am just listing out. Then now moving to the front end services, as we already mentioned, the very major component of your open cloud architecture, which is front end, open Nebula. When I say that front end Open Nebula, what is the major services it can offer? Means the two major services it will offer. The first one is management daemon, the other one is the scheduler. So first service, it is named as 1D. I hope it is visible to you all. It is named as 1D. It is used as a it is used for management, as it says that management. So what it will be managing, it will be managing the cloud resources and orchestration of the VMs and providing the communication with the hypervisor. All those will be managed or taken care by the one such service at the front end, which is 1D for managing. There is one more other service which is schedule. It is SCHED, which is SCHED, which will be acting as a scheduler. What it is scheduling? It is scheduling the resources. That's what allocating the resources and deciding which host, okay, which host should contain, or which host should run what. Okay, that is what will be scheduling by this scheduler, what you call as schedule. So these are the two core services taken care at the front end. That's what as a part of front end services. As I'm talking about front end services, so you definitely need a interface for the user. That's what we say, that web interface. For the user interface, we have one such, it is Sunstone server. This, by using this Sunstone server, it will be actually giving very effective user interface mechanism which provides the user-friendly web portal where user can manage the VMs. Okay, see how best you can utilize. So that's what for the user interface we have Sunstone server. For the web, it is a web interface mechanism. So that is, so these are the services, like two core services, and for providing the user interface service we have the Sunstone service. Similarly, I'll come to this advanced tools later. Similarly, there is a database services. For database services, we will be using a SQLite. You all are aware about that, which is the lightweight database management system, where majorly used for the small scale development process. So in such case, we'll be using the SQLite. Okay, and that's what you can observe. It is majorly used for the testing purpose, defaultly used for the testing purpose. Then again, as usual, you have a MySQL, which is used in the production, as which where we are also going to use that MySQL installation and usage as one of the topic in the future class. So these are the two more services which are as a front end services. Now let me show you some advanced tools like OneFlow, OneGate, and Econ. OneFlow, OneGate, Econ. So we have three advanced services. What you call it as OneFlow is a service to manage the multi-tier. As we already mentioned in the previous one of the topic, which is multi-tenancy is so important, which will be your OpenAbula is providing the multi-tenants application. So for that we'll be using this OpenFlow. Then we have a multi-gate. It is to provide the communication across all the VMs, and also it will give the complete analysis. The next is Econ or Econ, whatever you call it as, which will give you the cloud federation. It will enable the cloud federation where it will actually allow you to share the resources like this. These are the different services which we will put it under the front end services of your open cloud architecture. There are, if you ask me for what and all you can monitor by using this OpenNebula, that's what monitoring in OpenNebula. So it is not only with respect to the OpenNebula, it is with respect to any kind of cloud administration or cloud architect for that matter. So cloud auditing is so important. Here also monitoring is one such kind of auditing process only, right? So this monitoring in the OpenNebula is a very important functionality to keep on checking the performance and resource utilization. So performance of the infrastructure and also the resource utilization, you will be keep on checking. What are you checking? You will be checking the host status. The host status or the node status, which will be comprises with the different infrastructure like CPU, memory, okay, disk IO, all that. So similarly, you will also be keep checking the usage of the VMs. It is those VMs only which are placed above the hypervisors of the host. You'll be keep on checking the utilization of such kind of VMs. So how much CPU is utilized. Okay, what I'm trying to convey, you have a hypervisor. You will be keep on checking the utilization of this hypervisor. Similarly, you will also be keep checking the utilization of this individual VMs which are placed above the hypervisor. So both are means of you call it as auditing or you call it as monitoring, right? So you will be keep on collecting the data related to that particular resources, like both hosts and the VMs, in a very periodical manner. For every timely manner, auditing will be keep on happening. So what is the purpose? If you ask me, what is the purpose of this monitoring or the auditing? It is very simple. It will allow you to plan further. If you think that there are the so and so resources which are underutilized, it's something like you unnecessarily allocated 16 GB RAM, but only 2 GB is utilized or maximum 3 GB is utilized. In the sense, you can think of reducing the resource which is getting waste. So such kind of underutilized resources, you can reduce that and see that. Similarly, if there anywhere, if your resources are overutilized, something like for the so-and-so VM, you allocated only 2 GB RAM, but you can see that VM is completely using the 2 GB RAM. In the sense, definitely you can think of increasing to the 4 GB, right? So that capacity planning will be, capacity planning and optimizing the resource allocation, and also detecting the anomalies, which is abnormalities or issues, and troubleshoot them to increase the performance. So all these are the outcomes or the purpose why you need to think of monitoring or auditing in any cloud for that matter. It is not only in the open nebula I'm talking about, right? So that's what monitoring will give you the possibility to stay, manage the cloud services in a stable, efficient, and reliable way. Then virtualization host, already we saw in the one of the previous slide. There are the two virtualization hosts we are talking about in the open cloud architecture. One is the KVM, which is for managing the virtual machines. For managing the containers, we have a Linux based LXD, right? So for KVM, it is to manage the virtual machines. LXD is to manage the containers. What exactly it will be doing? Obviously, it is be supporting the I would say they will be acting as a hypervisors, right? Both KVM and the LXD both will be acting like a hypervisors, but KVM will be managing the virtual machines, LXD will be managing the containers. Then can I do the clustering? That's what a grouping for making sure that load balancing and resource scheduling will be easy. So definitely the OpenNebula will give you the option for clustering. Next, if you ask me what are the best practices in the virtualization in the open cloud architecture means, so it can maintain the homogeneous configuration of the VMs across the infrastructure which is created. Then what is the role of the virtualization in the open cloud architecture? So you all know that you can virtualize the available physical resources and use them in a efficient way, right? So that is a one major advantage we can think of. So that is what the impact of virtualization in the open cloud architecture. Now again moving to this, already we saw this in the one of the previous slide if you remember. So storage was one such component. Once data stores or the storage was one such component of your open cloud architecture. So which are to manage store and manage what in the sense VM images, templates, and the other files, right? So all those can be stored in this storage, and in this storage disk can be communicated or they can be organized majorly by using your SAN, just storage area networks. Okay, if you ask me what are the different classes of data store, this again we saw in the previous slide, right? One of the previous slide. We have system storage, we have system data stores, which is to store the images. That's what active disk images of your VMs. So then we have a image data store, which is to store the image templates. Image templates are stored, which is the base images, and they all those how the new VMs can be created at that time, how it has been deployed, all that which are stored in the image data store. And we have one more storage class in the data store. One is that is what file data store, which is will be storing the non-disk files. What are those non-disk file in the sense? It can be init, which is initialization random disk file, kernels. We have other context files which are required for the required in the virtualization. So all those will be stored in this data store, and these are the three categories or three classes of data store: system data store, image data store, and the file data store. Then if you ask me what are the different storage supported storage technologies in the open cloud architecture means, so obviously for we have as usual file system that support the SSH for secure storage. Okay, then QCOW. Actually this is one such kind of images which will be used majorly in kind of whenever you think of you wanted to create your own startup. In that startup you want to have your own email VMs. Okay, and those VMs you don't know whether they can be functioning properly or not. So because you are doing as a kind of a startup and you need to test for your simple protocols, in such case we'll be using this QCOW images. Okay, then we have other file system or other storage mechanism, which is LVM, which is logical volume manager. So for storing the high performance block storages, majorly will be used this LVM. And there is one more storage medium under this OpenNebula, which is Ceph. Okay, This is something different and useful compared to other, because it will provide you the distributed storage mechanism. Okay, it will follow the, or it will provide us the distributed storage mechanism. So this is somewhere has an advantage over the other two mechanisms in the open nebula, or you can say that open cloud architecture data storage mechanism. Next, as we saw, to connect all those core components like front end, okay, hosts, and also the data storage. So one should have the mechanisms to connect them and provide the better communication. For that, you need to have a better networking as well. That's what networking in the open nebula for providing both. It is to manage the operations and virtual communication between what? Between all those core components. So for that, we have the three physical networks. One is the service network, and two service network and the instance network. When I say that service network, it is to manage the traffic. When I say that, so manage the traffic in the sense, so it is where when the VM is scheduled with the resource or task, and for monitoring, which is auditing, okay, and whenever you want to transfer the image, VM images from the host to the data store, all those will be taken care by this service network. There is other network which is called as instance network. As the term says that it is to instance network, which is to provide the communication among the VMs. Okay, I'm repeating again. Service network is to connect three entities. One is the data store, front end, and the host. Because inside the host you have a hypervisors and the VMs. Inside the data store you have a storage mechanism. This is the front end. To connect all this, we have a service network. Whereas inside the host we have a hypervisors, and above the hypervisors we have multiple VMs. To provide the interconnectivity between these VMs, we are using this instance network. Okay, those are the two types of networks we can point out in the open cloud architecture. Then if you ask me what are the different type of networking drivers which are supported, in the sense, one major thing is dummy, which is it doesn't require any kind of isolation. Okay, so it will be majorly used for the testing purpose. Then again, we have, as usual, you all know that it is a firewall is one such network driver for traffic filtering. Again, we have 802.1q, which is majorly will be used with respect to the wireless and also the VLAN. So VLAN networking, which where will be using this 802.1q, where majority you may see connecting maybe a physical communication, or it can also be the wireless communication. So it can be, in such cases where you may be using this 802.1q. Then we have three drivers, which is EB tables, OV switch, which is open virtualization switch, okay, and VXLAN. See, these three cases where we'll be utilizing as a type of this instance network to provide the communication among the VMs. Okay, I repeat, these three, which is EB tables, OV switch, and VXLAN, majorly will be using to provide the communication among the networks, just like the instance networks, right? So that's how VM communication is so important, and for that we'll be using this EB tables, OV switch, and the VXLAN. So that is what the networking in the open cloud architecture. Next, so for authentication service, again we have a separate topic. We will be discussing about this authentication in detail. But as an example, as a one of the scenario here in the open nebula, yeah, it do provides authentication to make sure that authorized users and administrators only using your resources. So no means of thefts, or no means of intruders bypassing your authentication system. So to make sure that we have the different supported authentication systems or authentication mechanisms. One such is, you all know that it is based on the username password, which is a default mechanism, right? So it is a default way, username password. The other one is SSH. Okay, we have this SSH in with respect to both. So all that we'll be discussing in detail in the further topics. I'm just highlighting. So SSH is also supported here and where it will be managing both private and public key paste. So it will be, it will give you very, very secured access management. Then we have a certificates, which is X 5.9 certificates. It is not only, see this, what I'm trying to convey, this username password, SSH, X 5.9, LDF, LDAP, which is LDAP. So all these are not only for Open Nebula. These are just like in an other security mechanisms also we are using this in any secured communication. What I'm trying to highlight, your Open Nebula also supports these secured mechanisms. So X 5.9, when you talk about certificate, obviously it is a certificate based authentication. We have the different fields which are there in the certificate. Every field has its own purpose. That's what we say, the subject matters. Next we have a LDAP, which is lightweight, which is, you see, the directory access protocol. As the term says that it is, I wanted to highlight this directory in the LDAP. It is not for you to, deal with the login logout, general normal login logout. No, I'm talking about directory access, directory login. That's what we say, that it is a centralized mechanism that will allow you, you means it can be the user, individual user, or it can be the any institutions or the organization credentials will be having, right? So based on that, one can try to access the directories. So that's what directory access protocol. So likewise, Open Nebula or Open Cloud Architecture do allow or provide the authentication by using these four type of supported mechanism: username, password, SSH, X5.509, and LDAP. So in detail, we'll be discussing in the future topics, right? So uh, what else services which are offered here by in this Open Cloud Architecture means. So obviously one such is OneFlow. As we already mentioned, it is for multi-tier applications. To manage such kind of multiple VMs in the multi-tier applications, we'll be using this OneFlow. Then we have a cloud bursting. So usually this, whenever you wanted to think of combining the multiple clouds, making it as a hybrid cloud. In such case, where we'll be using this cloud bursting is one such component. Then one more is interface, which is public cloud interface. Where that's what, whenever you wanted to have a, as an example, you built up one private cloud in your own data center. Later you wanted to have an interaction with the EC2, where that EC2 is built up on the AWS. In such case, you need a interface, which is public cloud interface. So that is also provided. Then again, one gate, it is to keep on auditing the respective VMs on the host and keep on giving the analysis. So for that we'll be using the one gate. So like this, these are the different kind of different components we have in the Open Cloud Architecture. So till now I just spoke about the only about the one topic, which is the Open Cloud Architecture. So it is this, so which has four different components, and on every component we deep dive into the every component. Like under the host, we have the two different types of hypervisors like KVM and the LXD. Then we saw in detail about the three types of data stores. Okay, again, front end configuration, what is required. We saw the two types of network. One is a service network, the other one is an instance network. Like that, in detailed dive into this cloud architecture. That's what we saw till now. Yeah, any doubts on this?
Sir, I have few, sir.
Yeah, please.
Uh, uh, with my understanding of Open Nebula, means this is the Open Nebula is the alternate for Azure and AWS. Am I right, sir?
Very basic thing, yes. So see,
Okay.
basically, even when we started using that Open Nebula and Azure, so definitely you'll have to pay for those services, right? And also second thing is that whenever you wanted to implement as a new mechanism, that's what when we saw in the previous topic as a overview when I gave you, majorly it can be used in the this thing research labs as well. When I'm using in the research labs, can I use it? Can I use the AWS directly? So it will, the majority of APIs will not allow me to use it for my research work. In such case, I'll be using this Open Nebula. If you ask me, is it a kind of alternative to create your own private network? Yes.
Okay. So here, as a application, those APIs, those things are open source, but for the physical machine or those things we need to pay. Correct, sir?
Obviously, it is you see you
Okay.
are, yeah. See, example. Let me tell you. I hope whenever you install the virtual machine in the so and so lab systems, it is the lab system. For that system, you have to pay. It is you see wherever whichever the virtual infrastructure you talk about, virtual infrastructure it can be created above the physical infrastructure only. Okay, for that physical infrastructure, definitely you have to pay and buy. You have to get the physical infrastructure. So physical infrastructure is, yeah, if you ask me, like, to where you are creating the private network or sorry, private cloud, that physical thing you will have to pay, definitely yes.
Okay. Uh, so that is one thing, sir. And another one is in the lab, we tried installing because since it was done everything on a command prompt, I was not aware of the importance of each command there. But now, when you taught or when you explained, we tried a few of those commands like open nebula gate, open nebula flow, all those
Yes,
things we
yes,
used.
yes.
While doing like something called apt hyphen I
Correct.
mean, space install and open nebula flow, open nebula gate, open nebula sunstone, all
Yeah,
those things.
yeah,
So
that's what we are highlighting. Yes, correct.
uh, 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 uh. So but then with those whatever IP we got with along with the port number, we logged in. So
Correct.
with that we are concluding that there is a I mean there is a interface of OpenNebula we have installed on a particular machine. This is what what we can
Exactly.
understand with the program.
Exactly. So that is where, so whenever you started doing with respect to by using every individual command, so similarly you would have also set the network, data store capacity, VM related, how many VMs you want for every VM.
Uh,
Yeah, yeah.
No, but in that program we didn't specify anything about number of cores or a RAM or those specification we didn't mention in those any of those commands. Maybe it will take
No,
maybe
so
something default it would have taken.
yes. So whenever, exactly, that's what I was highlighting here. It is a basic recommended configuration only. I just highlighted here. So whenever you wanted to customize and if you want to increase mode, then you have to explicitly mention how much else you want. If you don't mention, then default package will be installed.
Okay, okay, fine. And there we tried this OpenNebula on a Cloudera.
Hmm.
Cloudera. So there we are using Cloudera as a hypervisor there.
Hmm. Yes.
Okay, fine, sir.